Okay. Or let's say, for example, that I draw a cube out of this container here. All right. I know that when I draw out a random cube, that's my random variable, right? Well, what am I going to get? I'm either going to get a black, or I could get a pink, or I could get yellow, or blue, or white, or brown, or orange. Okay, I can get any of these colors, but I know that I'm not going to get a purple cube because there are no purples in here, okay? So there's only a certain number of options that are going to happen. And those options mean that my random variable is discrete because it can only be certain things. All right, so a variable is discrete if there are separate, distinct possible outcomes. Now, discrete random variable, two things are true. One, the possibility of each outcome has to be between 0% and 100%. Which is to say that the possibility of each one has to be between 0 and 1. And then the sum of all the possibilities together is 100%. So, there's a possibility of me getting green, and I could count how many greens there are, right? And come up with a probability for getting green and a probability for getting red, probability for getting white, right? Well, each of those probabilities is not like 200%, right? It's a probability that goes between 0 and 1. And if I add up all the possibilities, when I reach in here, I know I'm definitely going to get a cube of some sort, right? I know I'm going to get a cube for my answer. So the sum of all the possibilities, red plus green, blue, etc., has to be 100%, which is to say something is going to happen, right? Okay, now so we can just so we can contrast that with continuous variables. So a continuous random variable would mean that the possibilities run together. So a good example of this is like the normal distribution. So in the normal distribution, you have all of these different possibilities, right, that could happen. All these different possibilities down here. Any of them could happen. And so the answers are more about intervals. Okay, what's the possibility that it falls in this interval? Okay, and so the possibilities, instead of being discrete, are continuous along a smooth curve, right? And instead of talking about the total possibilities, each one adding to one, we're talking about the area under the curve, the entire area being one. So that's the difference between discrete and continuous. But for this video's purpose, we're going to be talking about just discrete variables. All right. So variables in general are described by parameters. So parameters are numerical summaries of a population. So parameters are anything like the mean, the standard deviation, the mode, quartiles, range, interquartile range, any that data, those are all parameters. And that brings us to the main thing that I'm going to want you to be able to do from today's lesson, which is the meat of it here today is about finding the expected value. So what is the expected value and how can you find it? Well, the expected value is the outcome that you would expect to get over the long run, the outcome that you should get if you continue to do the experiment over time, right? So the expected value is actually the same as the mean, the average, which you guys already know about. So the expected value is actually the same as the average. It's what you're going to get over the long run. All right, so what is it as far as formula? Well, to find the expected value, it is the sum of each particular option times the probability that each option happens. So the expected value is whatever option 1 is, times the probability that option 1 happens, plus whatever option 2 is, times the probability that that happens, plus whatever option 3 is, times the probability that that happens, and we have to do that on and on for all the options. So it's the sum of each probability times each option times its probability. In a more of a mathematical formula, we could write it like this. We have x times the probability of x1 plus x2 times the probability of x2 plus x3 times the probability of x3, and we have to do that for each of the x's. So in general, the expected value is the same as the mean or the average, and it is the sum of each x times the probability that it happens. This formula here is your friend. So here's a quick example then. Let's say that you're watching a random baseball game, okay? San Francisco's playing, and you're wanting to know what is the expected number of home runs that you expect this game. How many home runs can you expect to have? Well, you pull out your stats for the year, and you see that. And you can see that that the probability of having 0 home runs is this number, and the probability of having 1 home run is this. And you can tabulate all of these. The probability of having more than 5, the probability of having more than 5 home runs is actually 0. That never happened the whole season. Okay, so now we can use this data to find the expected value. So what we're going to do to find the expected value is we're going to multiply 0 times the probability of 0 plus 1 home run times the probability of 1, then 2 times its probability, and then we're going to add that with 3 times its probability, and so forth, and add them all up and see what we get. So the expected value is 0 times the probability plus 1 times its probability plus 2 times its, 3 times its, 4 times the probability of it being 4, of there being 4 home runs, and then 5 times 0. And when we add them all up, we get 1 for our expected value. So what does that mean? So in any one game that's being played, I would not expect there to be, there's not going to be 1 home run in every game that's played, right? But if I'm just watching one random game, since the expected value is 1, I would expect that in a random game, I'm probably going to see about 1 home run. There will not be 1 home run in every game I watch, but in general, if I'm watching a random game, I'd expect 1 home run. That is how you find expected value of a discrete random variable. That is how, wait. And that is how you find the expected value of a discrete random variable.